Hi there, Mr. Biggers here, and today we're going to jump into Module 5, Lesson 4, and we're going to be learning about the remainder and factor theorems. So at the end of this lesson, I hope that you can evaluate functions by using the synthetic substitution, and I hope you can use the factor theorem to determine the factors of polynomials, okay? So we're going to be jumping back into synthetic division. So if you don't remember that, I would recommend going back, watching the videos on synthetic division way back when we did that. And then come back to this video. But if you don't remember, it's okay because we're going to do some practice and hopefully it will help you remember pretty easily. So just before we start, we're going to be dealing with the remainder theorem today. So we remember that the remainder theorem is pretty much, well, this is going to be new. The definition of this is kind of going to work out with the problem. Okay, so an example here is they are evaluating this guy when x is equal to 5. So the big thing here is that when x is equal to 5, we've got to think of this guy as a term, okay? So if you were solving a quadratic, if you got x equals 5, one of your terms would have been x minus 5, right? Because if you had to solve that, you'd have to set that equal to 0, you'd add 5 to both sides, and then you'd get x equals 5. So really, when they give us like x equals 5, we need to think of this term, x minus 5. Because if you remember when we did synthetic division, we had x plus a, okay? So we always paid attention to whatever that a value is. So in this case, that a value is negative 5. So that negative 5 is what we would put in our synthetic division box. So it's going to be opposite of kind of what it's going to be equal to. So make sure you kind of understand that, and I'm going to explain that just a little bit, okay? So we also want to remember to include our missing terms. So there's going to be more on this on the problem that we have below, but do write that down if you're writing on notebook paper so that way you can have that. Okay, so example 1, we're going to use synthetic substitution. So it says use synthetic substitution to find the function at negative 3 if f of x is equal to negative 2x to the 4th power plus 3x squared minus 15x plus 9. Okay, so remember that when you're using synthetic, you will set it up like a big old subtraction problem. Okay, so here's an example. If they want us to do the function at 2, what we really need to think of is the term, okay? They're saying x is equal to 2. Well, if x is equal to 2, that means that the actual, like, factored term of that would be this, okay? So when we're doing synthetic division, the number that you would need to think of for this type of problem is literally negative 2. So that would be the number that you put in your synthetic division box, okay? So that's what I want you to write there. So if they gave us f of 2, the number you would need to put in the box is actually negative 2, because remember, we're thinking of that quadratic term, that linear term that we would factor out of a quadratic, okay? So in these types of examples, if you're finding f of negative 3, like our problem that we're working on asks us to do, the number you will need to put in the box is actually positive 3, because we're really dividing it by this term, okay? Remember, synthetic division, we've got to divide by that number. So that number is going to go here. Then you just need to look at your exponent terms. So what I'm going to do here is copy down the function that we have. We have f of x is equal to negative 2x to the 4th plus 3x squared minus 15x plus 9. Now, don't get carried away with synthetic division, because this is what I talked about with our study tip up here. Missing terms, okay? I go from x to the 4th, and then we jump down to x squared. So really, right here, we are missing a term. So what we're going to do is we need to think of that as plus 0x to the 3rd, because that term's magically not there. So what we're going to do over here on our synthetic division when we're writing this problem out is write the coefficients of everything. So we have a negative 2. Remember, we're going to sub in that 0. And then we have a 3, then a negative 15, and then a 9. And this is where I'm going to jump through this pretty quick here. So remember, synthetic division, big old subtraction problem. You're going to be subtracting everything. And at the end here, you're going to have another little box, and that is your remainder. Did I spell that right? Remainder. I totally did not. But that's your remainder. Okay, this is where the remainder theorem is going to come into play. So first things first, we are going to go ahead and solve this synthetic division. So if you remember, you bring down your first number, you start here with a negative 2. So then you're going to do a 3 times negative 2. 3 times negative 2 is going to get you negative 6. Don't forget, you're doing a big old subtraction problem. So you have 0 minus negative 6, which is the same thing as 0 plus 6. 0 plus 6 is 6. Then you have 3 times 6. 3 times 6 is going to get you 18. Okay, now we're doing subtraction. 3 minus 18. So that 3 minus 18 gave us negative 15. Okay, then we're doing the 3 times negative 15. 3 times negative 15 is negative 45. Okay, don't forget, we're still doing subtraction here. And I don't know why this 189 is in here, so let's get rid of that. Okay, so negative 15, and then you're taking away negative 45. Okay, so negative 15 minus negative 45 is going to get you a positive 30. Okay, then our last thing here is 3 times 30. So 3 times 30 is going to get you 90. And then all you have to do here is subtract that. So 9 minus 90 is going to get you negative 81. Okay, so this is the remainder theorem. Okay, so pretty much what it says is the remainder is literally like if we plugged in the negative 3. Okay, so it should be negative 81. Okay, so we are going to check to see, is this correct or is it not? Using direct substitution, like you guys already know how to do. Okay, so what we're going to do here is plug in the negative 3. Answer should be negative 81. So let's see what we get really quick. So I've got negative 162 plus 27 plus 45 plus 9. And my answer is surely negative 81. So using synthetic division, you can find literally answer. Like, it's a lot easier to do that than to just plug it in like this. Okay, so that is the remainder theorem. So we have another example that I want to use here. And yeah, so if you need to rewind that to hear any steps, please rewind that. But we're going to kind of continue on the same thing here. All right, so example 2, use the remainder theorem to find P of 2. So remember, you want to think of this as the linear term. So if they're plugging in 2 for x, that means x is equal to 2, which we need to think of it as the actual factored term, okay? Because when we set up our synthetic division, that negative 2 is what's going to go in the box. So we are going to go ahead and set this up, the synthetic division. So negative 2 goes in the box. And then we need our leading coefficients to go ahead and set up these numbers. So we have a negative 1, a 3, a negative 4, and a negative 7. So it doesn't look like we're missing any terms, so we're good there. And then remember, that's our remainder box. And so the remainder theorem says that that should be the answer if you plug in a 2. Okay, so what we're going to do here is easy peasy, get this done. So negative 2, and remember this big old subtraction problem, negative 2 times negative 1 is going to be 2. 3 minus 2 is 1. And then we have negative 2 times 1, so that's going to be negative 2. Then we have negative 4 minus negative 2, which is going to be negative 2 because you're adding. And then we have negative 2 times negative 2, which is positive 4. So negative 7 minus 4 gives us an answer of negative 11, I believe. Yes. So this should be the answer. And you can check that by plugging it in if you want to. But what you can do here is P of 2 is equal to negative 11. So as long as you're doing your synthetic division correctly, you should be getting that answer. Really quick here, I'm just going to plug it in to check. So we're going to plug in a 2. So I've got... this is the actual original function. If you don't want to see this part, go ahead and skip ahead in the video because I'm just going to check the work. So plugging in a 2. And then, so 2 to the third power is 2 times 2 is 4, times another 2 is 8. So negative 8 plus, that's going to be 4 times 3, which is 12. Minus 8 again, minus 7. So that's going to be negative 8 plus 12 minus 8 minus 7 is equal to negative 11. So if you wanted to plug that in and check, we got the same answer, so it works. Okay. Obviously, the synthetic division can be a lot easier than doing that, especially if you have a huge freaking polynomial. Okay. So the factor theorem pretty much says that you can write one of these things as a product of the quotient or the answer of the division problem and what you divided by. So in the problem we just did up here, the divisor, the thing that we divided by was this guy. Okay, so that would be the divisor. And then you can write it as a product of the quotient and the divisor. Okay, So what they're saying here is it's a factor of the polynomial if you don't have a remainder. Okay, so if your remainder is a 0, then whatever you're dividing by is legit a factor of the polynomial, because you would plug in that value, you would get a 0. So that would be a solution of your function. Okay, so we're going to use the factor theorem to find this. This is like kind of just putting together everything that we've done all into one. So we want to show that x plus 8 is a factor of this. Okay, so it looks like we already have it in our form that we need. So in our box is going to be an 8. And then we're just going to copy down the rest of the problem. So we've got a 2, we've got a 15, we've got an 11, negative 11, and a negative 24. So we want to subtract this out and see what we get. So 2 is going to come down. 8 times 2 is 16. So then we have that's going to be negative 1. 8 times negative 1 is negative 8. And then remember, minus a negative is really going to be a positive. So this is going to be negative 3, I believe. Let me check. Negative 11 minus negative 8 gives you negative 3. That's good. And then 8 times negative 3 is negative 24. And then negative 24 minus negative 24 is, in fact, 0. So if you are left with 0, that means it is a factor. Okay? So then we have to find the remaining factors of the polynomial. So all you have to do is rewrite this. Okay? So we're going to use that theorem above to rewrite it. So we have the quotient. So the answer that we got in yellow. So it's going to be 2x squared minus x minus 3. Okay, that's our quotient, times the actual factor that we tried, which was x plus 8. Okay. And then they want to find the remaining factors of the polynomial. So what you would need to do here is see if you can factor this. So we're going to do, it's in quadratic form, so we're going to see if this is factorable. So I'm doing a times c, so 2 times negative 3 is negative 6. And then factors of negative 6 that sum to negative 1, I'm thinking negative 3 and 2. Okay, so then we're going to factor by grouping. So we got to split up this middle term. And I'm going to write all these steps over here in just a second. So this is going to be 2x squared. We're going to split up that middle term. Minus 3x plus 2 minus 3. And then we are factoring by grouping at this point. Okay, and don't forget, I forgot my x on there. Okay, so then you're just going to take out the GCF. So it looks like these two terms have just an x in common. So then you're left with 2x minus 3 plus, take out a 1 because that's all they have in common, 2x minus 3. So since your insides are the same, you can rewrite this as a product of factors. I'm running out of room here, so what I'm going to do is try to scoot this up just a smidge so that way we can fit everything. And it's kind of over the words, but that's okay. Okay, so what we're going to do here is we're going to take our front two terms. Remember, those are going to be in 1, so that's x plus 1. And then the next term is going to be 2x minus 3. And then we need to look here, am I forgetting anything? And the answer is yes, because we literally just factored that part. We still got to use the factor that's on the front, the x plus 8. So x plus 8 is going to be out this way. Oh, and there went my notes. But if you pause the video, that was how you do that. So how do we do the steps here? So the first thing I would say is use synthetic to find if it's a factor. Okay. From there, rewrite. You would want to rewrite it as a product of the quotient and the divisor. Okay. And then step 3 is factor further, like we did. Okay. So if you need to pause the video at any point, please do that. Please make sure you ask any questions if you have any. And there are a few Alex questions to go along with this.